Hello, this video is about electric motors and how they work. We'll take through sort of a few steps of the process. But first of all, what is an electric motor? Well, it's a coil of wire connected to a direct current and inside a magnetic field. And where a magnetic field interacts with electric current, you get movement. So that's what the motor is doing. It's essentially turning electrical energy input into a kinetic energy output. So how does it work? You'll need to know your Fleming's left-hand rule here. FBI, force, magnetic field and current on your three fingers. So if we look at this side of the circuit, now the electric current is flowing conventionally from positive to negative, so around the circuit like this, so the current's flowing that way. So I'll put my middle finger this way. The magnetic field is always north to south by convention, so that's pointing that way, and so we can see this side is going to experience a force upwards like this. On the other side, the current's the other way, so the force would be downwards. So this, first of all, has an electric current through it. Secondly, as a result of the magnetic field, it then experiences a force that pushes this side down and this side up. So it starts to rotate. Now when it gets to the top, a little momentum carries it over, but if we didn't have this component, the split ring commutator, it would just go like that and stop. But with this split ring commutator, as it passes sort of 12 o'clock, if you like, this changes the polarity. The different sides of the ring touch the other sides of the circuit, and the current again flows the same direction, so it continues to spin. Without that split ring commutator, you wouldn't have a motor continuing to flow, but as it is, it just spins and spins, and you've turned electricity into kinetic energy. Hope that was helpful. Thanks for watching.